We are on video 4 in a really long series on solving linear equations and inequalities in one variable. So I'm going to do this in 3 parts. Part 1 is going to be on just solving linear equations in one variable. Part 2 is going to be on problem solving or word problems. And then part 3 is going to be on solving linear inequalities in one variable. So we're on video 4, part 1. All right. And in this video, what we're going to do is we're going to look at solving equations that contain fractions. So let's pull up the whiteboard. Okay. So again, in this video, we're going to look at solving equations that contain fractions. So all the previous video, the steps to solve an equation. The next step we would want to do is look to combine like terms on the left or right sides separately. So you want to make sure that the left and the right hand side have at most one variable term and one constant term. The third step is where you start moving stuff around. So in the third step, you want to get all variable terms. So all variables in a single term. On one side of the equation, generally the left. And all constants in a single term. Whoops. In a single term on the other side. And then the final step is where you officially solve the equation. This is where you have a single constant term or a single variable term equaling a single constant term, and you want to undo the multiplication of the variable and its coefficient. And we do that by dividing both sides by the coefficient of the variable. So this is what we really practiced in the previous video, in the video where we looked at solving multi-step equations. For this video, we want to know, well, what happens if we have a lot of fractions? So what happens if the equation contains fractions? We already know, most of us know anyway, that fractions just complicate matters, okay? Generally speaking, students don't love fractions. They find fractions to be a little bit complicated, a little bit hard to work with. So if you have an equation with a lot of fractions, it can just complicate the whole process. So what we do is we eliminate all fractions. So we eliminate all fractions first and then solve. All right, so this right here is very important. So now, how do we eliminate fractions? Well, the first step is to find the LCD. So look at all of the denominators in your equation and figure out the least common denominator, the smallest number all of your denominators would divide into. You then want to multiply all terms by the LCD. And then you simplify. So when you multiply all of the terms by the LCD, what you're going to see happen is all of the denominators are going to cancel out and you're going to be left with just all integers. So that right there, step 1 and 2, you're going to end up eliminating all of the fractions and you'll just have a bunch of integers in your equation and it would be just like the previous video. So step 3, you simplify. And then step 4, solve like normal. So again, we already know the 4 steps to solving an equation. We clear fractions, we combine like terms on either side separately, we get the variables on one side together, you get the constants on the other side, divide both sides by the coefficient of the variable, and now we've added this new layer of, well, what do we do if we have fractions? Get rid of them. All right, so if you can practice getting rid of fractions, you can take what could be a very complicated equation and really make it pretty straightforward and easy to solve. So let's go ahead and look at examples. So we'll look at some examples. Whoops. And shoot. There we go. So examples. The directions will just say clear or eliminate fractions and solve. Now, one thing I will say is a lot of students, they try to just work with the fractions, and that's not really wise because fractions just complicate everything. In this case, I want my students to eliminate the fractions and then solve. So part of what I'm grading, part of what I'm looking at is your ability to get rid of those fractions. So let's go ahead and look at some examples. So first up, let's say we have 5/4 x minus 1/3 x equals 11 halves. So we have 3 denominators. We have 4, 3, and 2. We want the smallest number that those 3 denominators would divide into evenly. So the good news is, like, when you first learn how to deal with fractions, finding the LCD can be fairly difficult, but at this point, the LCD is going to be generally pretty straightforward. So here, the smallest number 4, 3, and 12 and 2 would all go into would be 12. So now what I'm going to do is I'm going to show this step. I'm going to take all 3 of these terms and I'm going to multiply them by 12. You can always tell the different terms because they're going to be separated by plus, minus, or equals. So I've got 12 times 5/4 x minus 12 times 1/3 x equals 12 times 11 halves. And what you should see here is that each of the denominators will divide evenly into that LCD. So the 4 right here, it will go into the 12 3 times. The 3 in the second term will go into the 12 4 times. The 2 in the last term will go into 12 6 times. So we've found the LCD. We've multiplied all of the terms by the LCD. Now we want to simplify. So I have 3 times 5x, which is 15x. I have negative 4 times 1x, which is negative 4x. And then I have 6 times 11, which is 66. So if you look at this right here, we found the LCD. It was really easy. We multiplied all 3 terms by the LCD, pretty easy. And now at this point, we're left with something that's not too bad to solve. This third step right here looks a lot easier than that first step. So let's finish the solving process. We don't have any parentheses, but we do want to look to see if we can simplify the left or the right-hand side, and we can simplify the left. If we look at the left-hand side, we have 15x minus 4x. That would simplify to 11x, and that's going to equal 66. So now we have a single constant term equaling a single variable term. So at this point, we want to do that final step to solve. We're going to undo the multiplication of 11 and x. So we divide both sides by 11. The 11s on the left cancel. I get 1x. And then 66 divided by 11 is 6. So the final solution here is 6. All right, so that is how you eliminate fractions. And again, for my students, I always insist that they eliminate fractions. That's part of what I'm grading them on, because trying to keep the fractions, it just gets far too complicated. So taking a couple of quick, easy steps to get rid of them, it makes the whole process a lot easier. Let's look at another one. Let's say I have 3x plus 7 over 6 equals x over 3. So in this case, I have an LCD of 6. 6 is the smallest number that both 6 and 3 would divide into. So I'm going to multiply each of these 2 terms by 6. So 3x plus 7 over 6 is a single term. And then x over 3 is a single term. Now I'm going to simplify. In the first term, I notice that 6 goes into itself 1 time. and 3 goes into 6 twice. Now I'm going to simplify. For the first term, I just get 1 times 3x plus 7. So that ends up just being 3x plus 7. I don't have to do any really difficult distributing. And then 2 times x is 2x. And now at this point, I'm just going to do the regular steps to solve. I don't have any parentheses. I can't simplify, but I do have variables in 2 different places. So I want to get those in a single term. So I'm going to take the 2x and I'm going to move it to the left. I would do that by subtracting. So that gives me 3x minus 2x is 1x plus 7 equals, well, the 2x's, they end up canceling. So 2x minus 2x is really 0. And since there's nothing to combine that 0 with, I'm just going to go ahead and bring the 0 down. Now I want to get my x all by itself, so I need to move the 7 to the other side. I do that by subtracting. The 7's on the left cancel. 7 minus 7 is 0. X plus 0 is just x. And then 0 minus 7 is negative 7. So our final answer here is negative 7. Let's just keep practicing examples. So next up, let's say that we have 4x minus 11 over 5 plus x over 20 equals x over 4 minus 1. So if I look at these 3 denominators, I have 5, 20, and 4. My LCD would be 20. So in the next step, I'm going to multiply each of these 4 terms by 20. Now notice we have a term that does not have a fraction in it. This minus 1, we still multiply it by the LCD. So I get 20 times 4x minus 11 over 5 plus 20 times x over 20 equals 20 times x over 4, and then minus 20 times 1. Now I'm going to take a second to simplify all of these terms. In the first term, 5 goes into 20 4 times, 20 goes into 20 once, 4 goes into 20 5 times, and then the negative 20 and the 1, it won't simplify, so we'll just multiply it out in the next step. So I'm going to clean things up a little bit, and I get 4 times 4x minus 1. You could distribute, or 4x minus 11. You could distribute at this point, but I usually wait until the next step to distribute. Next, I get 1 times x, so just x. Next, I get 5 times x, or 5x. And then finally, negative 20 times 1 is just minus 20. All right. So again, at this point, we have a nice normal looking equation with all integer values, nothing nearly as complicated as what we started with. So at this point, we want to follow the regular 4 steps to solve. I'm going to start by distributing. So right here, I have 4 that I have to distribute through 4x minus 11. So 4 times 4x is 16x. 4 times negative 11 is negative 44. Drop down the rest of the equation, which is plus x equals 5x minus 20. Now I need to combine like terms on the left. I do have stuff that could be combined. In fact, it's 17x because I have 16x plus 1x. So I get 17x minus 44 equals 5x minus 20. Now I do have variables on 2 sides of the equation and constants on 2 sides of the equation. So what we want to do is get all of the constants on one side and then all of the variables on the other side. So I'm going to start with the variables. I'm going to move 5x to the left. So I'm going to subtract 5x. 17x minus 5x is 12x minus 44 equals 5x is canceled to become 0. 0 minus 20. $12x equals, and then negative 20 plus 44 is 24. Finally, I need to undo the multiplication of 12 and x. I'm at that point where I have a single variable term and a single constant term. So I undo the multiplication of 12 and x using division. On the left, the 12's cancel, leaving just x. On the right, 24 divided by 12 is 2. So I would say my final answer is 2. So if you take just a couple of steps to eliminate those fractions, you have a pretty standard equation to solve. Let's look at another example. In this case, let's say that we have 1/4 x plus 2 equals 8x plus 11 over 8. That's an x right there. All right, looking at my denominators, I have a 4 and an 8, so that tells me the LCD is 8. And now what I'm going to do is I'm going to multiply all three terms. And remember, terms are separated by addition, subtraction, or equals. I'm going to multiply all three terms by the LCD. So I get 8 times 1/4 x plus 8 times 2 equals 8 times 8x plus 11 over 8 is a single term. Now I want to simplify where I can. In the first term, 4 goes into 8 twice. In the second term, there's nothing to reduce, so I'll just multiply that out in the next step. And then in the third term, 8 goes into itself once. So let's simplify, see what we have. For the first term, it's going to simplify down to 2 times 1x, or just 2x. 8 times 2 is just plain old plus 16. And then finally, I have 1 times 8x plus 11. So 1 times 8x plus 11 is just 8x plus 11. So now I have a nice normal looking equation to solve. I'm going to start by moving all of my variables to the left. So this 8x, I'm going to subtract it on both sides. On the left, 2x minus 8x is negative 6x. Drop down your plus 16 and your equals. The 8x's on the right cancel. They just simplify to become 0. 0 plus 11 is 11. So now I've got all of my variables in a single term on the left. I want to get all of my constants in a single term on the right. So I'm going to subtract 16 from both sides. Whoops, I usually do that in red. So I'm going to subtract 16, subtract 16. So on the left, the 16s cancel. They just simplify to become 0. So I'm left with negative 6x on the left. On the right, I'm left with negative 5. I have a single variable term equaling a single constant term. So I'm at the point where I want to undo the multiplication of the variable and its coefficient. So I'll divide both sides by negative 6. On the left, the negative 6 is canceled. They just equal 1. 1 times x is x. And then on the right, it won't simplify unless I write the answer as like a decimal. But remember, I mentioned this in the previous video. If you get a situation where the final division is not going to be an integer value, you want to leave your answer as a reduced fraction. So in this case, 5 and 6 have no common factors, but do note that we're dividing a negative by a negative, which would end up being positive 5, 6. So that would be my final answer. All right. So this is really just like solving regular old equations like in the previous video. You just have this extra step of having to clear your fractions. Let's look at another example. Okay, so we have 7x minus 15 all over 8, and then we have 11x minus 12 all over 10. As far as the LCD is concerned, this one you do have to think about it maybe a tiny bit more. So let's look at 10. So 10 goes into 10, but 8 does not. We would look at then 20. 10 goes into 20, but 8 doesn't. Next, we would look at 30. 10 goes into 30, but 8 doesn't. So next, we would look at 40. 10 goes into 40, so does 8. So the LCD here is 40. So we're going to multiply both terms by 40. So I get 40 times 7x minus 15 all over 8 equals 40 times 11x minus 12 all over 10. We're going to simplify. So in the first term, 8 will go into 40 5 times. 10 in the second term will go into 40 4 times. So let's clean it up a little bit. What I'm left with is 5 times 7x minus 15 equals 4 times 11x minus 12. So now we have just a regular equation we need to solve. So we're going to start by distributing. Looking at the left-hand side of the equation, I need to distribute a 5. So 5 times 7x is 35x. And 5 times negative 15 is negative 75. Now on the right-hand side of the equation, we're going to distribute a 4. 4 times 11x is 44x. 4 times negative 12 is negative 48. All right. So I've got variables and constants on both sides of the equation. I need to get all of my variables to the left, my constants to the right. So I'm going to start by subtracting 44x. I'm going to do that on both sides. All right. So 44x, we need to take that. Let's see, we need to subtract 44x, so we get 35 minus 44, and that's going to be negative 9x. Drop down your minus 75 and your equals. The 44s on the right cancel to become 0, so that just leaves me with negative 48. So I've got all of my variables on the left. I need to move my constants to the right, so I'm going to add 75 to both sides. That'll move that 75 to the right. So let's see, on the left, the 75s cancel, so I'm left with negative 9x equals, and then I get negative 48 plus 75, and that's going to equal 27. I finally have that step where I've got a single variable term equaling a single constant term, so it's time to undo the multiplication of x and its coefficient. So I'm going to divide both sides of the equation by 9. On the left, the 9's cancel. Negative 9 divided by itself equals just 1. 1 times x is x. And then 27 divided by negative 9 is negative 3. So there you have it. And that's it. Let's do one more example with a regular equation, and then we'll look at one word problem. So next up, we have 5/3 x minus 12 equals 3 times x minus 16. All of that is over 4. And then I'm going to add x over 12. So if I look at my three denominators, the smallest number they all go into is just 12. So 12 is my LCD. I'm going to multiply all 4 terms. Even that minus 12 that doesn't look like a fraction, it still gets multiplied by the LCD. I'm going to multiply all 4 terms by 12. So I get 12 times 5/3 x minus 12 times 12 equals 12 times 3 times x minus 16 all over 4 plus 12 times x over 12. All right, so take a moment, show the multiplication, and then start simplifying. In the first term, 12 is divided by 3, and you would get 4. The second term, there's nothing to reduce. The third term, the 4 will go into the 12 3 times. And in the third term, 12 goes into itself once. So let's clean things up. For the first term, I get 4 times 5x, or 20x. The second term, I just get 12 times 12, or really negative 12 times 12. So I get negative 144. Now in the third term, be careful. So we have this 3 where the 12 and the 4 reduce, but we also have the 3 in front of the parentheses. I'm going to start by multiplying those 3's, and I'm going to get 9 times what's in parentheses, x minus 16. And then finally, in the last term, I just get 1 times x, or plus 1x. Okay? So we took a couple of steps. We got rid of all the fractions. Now we solve. So the first thing we want to do is distribute. So I get 20x equals, or 20x minus 144 equals, just write down what you have. Even though it's not being distributed, always rewrite the entire equation after each step. Now we're going to distribute the 9. So 9 times x is 9x. 9 times negative 16 is negative 144. Don't forget your plus x. We want to combine like terms on the right, so I'm just going to rewrite the left-hand side for now. And then on the right, I've got 9x plus x, which gives me 10x minus 144. All right. So now I've got variables on 2 sides of the equation. I've got constants on 2 sides of the equation. Let's start by getting all of the variables on the left. So I'm going to subtract 10x on both sides. So on the left, 20x minus 10x is 10x. Drop down your minus 144 equals. And then on the left, or on the right-hand side, the 10x's cancel. They just become 0. And I'm left with minus 144. Okay. So now I've got the variables on one side. I need to move all of the constants to the other side. So I'm going to add 144 to both sides. On the left, the 144s cancel to become 0, so I just get 10x. On the right, the 144s also cancel to become 0. Since there's nothing to combine the 0 with, I'm just going to write it down. And then finally, we need to undo the multiplication of 10 and x. So I divide. 10 divided by 10 is just 1. 1 times x is x. And 0 divided by 10 is 0. So my final answer here would be that x equals 0. Okay, so let's do a quick recap. We already know that to solve an equation, we have to clear the parentheses. Then we combine like terms on the left or right-hand side separately. Third, we get all of the variables in a single term on one side, generally the left. We get all of the constants in a single term on the other side, again, generally the right. And then 4, we divide both sides of the equation by the coefficient of the variable. But what was presented to us in this video is, well, what do we do if we have a bunch of fractions? Fractions, we already know, just complicate things. So we already have a fairly complicated process of solving an equation. If we add fractions to it, it just complicates that process further. So what do? We eliminate the fractions. The way we eliminate fractions is we find the LCD, multiply all terms, all of them, whether they look like a fraction or not, all terms get multiplied by the LCD. You simplify, and then you solve like normal. So we looked at several examples of how we would solve equations that contain fractions. So finally, I want to do one word problem. Now, at the beginning of the video, I mentioned that the series of videos on solving equations and inequalities in one variable was going to come in 3 parts. Part 1 is just solving linear equations in one variable. Part 2 is going to be problem solving. And what you're going to notice in part 2 is we're going to use a process called direct translation to take the written word and convert it to an equation. At this point, I want to expose you to as many word problems as I can, but where you're given the equation. So my goal here is you'll be given the equation, you don't have to create it, but you can see the connection between the words and then how the equation comes about. So let's look at this example here. And this one's not too bad because you have a visual. All right, so we have that 2 rectangles have the same perimeter. Okay, so we have the first rectangle. It has a length of x plus 3 and a width of just x. We have the second rectangle. It has a width of 1/2. Well, let me do it on the other side so the numbers don't get squished. It has a width of 1/2 x and then a length of x plus 2. All right. So we're told to find the width x of the first rectangle by solving 2x plus 2 times x plus 3 equals 2 times 1/2 x plus 2 times x plus 5. Then use x to find the remaining dimensions. All right, so let's recall. Perimeter is the distance around the figure. So for a rectangle, perimeter is equal to 2 times the length plus 2 times the width. Okay, so if we look at this first rectangle, I'm just going to label it first and then second, so we kind of know what we're talking about. If we look at the first rectangle, the perimeter is going to be 2 times x, that's 2 times the width, plus 2 times the length, which is x plus 3. Now, we know that these 2 rectangles have the same perimeter, so we're going to set the perimeter of the first equal to the perimeter of the second. So if I look at the perimeter of the second, 2 times the width is 2 times 1/2 x, and 2 times the length is 2 times x plus 5. And if you look at what we just created here, that's the equation that was given to us. So we have the width of the first rectangle and the length of the first rectangle, both multiplied by 2. And then for the second rectangle, we have the width of the second rectangle and the length of the second rectangle. So we have 2 times the width of the first plus 2 times the width of the second, or 2 times the width of the first plus 2 times the length of the first, equals 2 times the width of the second plus 2 times the length of the second. And if we can solve this equation, we will get x, which is right here, that's the width of the first rectangle, and we can use that to find the length of the first and then the length and width of the second. So let's go ahead and start distributing. So I get 2x plus 2x plus 6 equals, now I do have one fraction here, but it's an easy one. 2 times 1/2 is just 1. So I really just get 1x. There's no need to do the whole eliminating fractions thing here. And then I get 2 times x plus 2 times 5. All right. So we want to combine like terms on either side. So I get 4x plus 6 equals 3x plus 10. I want to get all of my variables on the left, so I'm going to focus on this 3x. I'm going to subtract it from both sides. 4x minus 3x is just 1x. So I get 1x plus 6 equals, well, the 3x's canceled to become 0. 0 plus 10 is 10. Now I need to get all of my constants on the other side, so I'm going to focus on the 6. I'm going to subtract it from both sides. 6 is canceled, so I get x equals 4. So for the first rectangle, we have that x equals 4. That's the width. And we have x plus 3, or 4 plus 3 equals 7 for the length. And if we look at the perimeter, we get 2 times 4 plus 2 times 7, or let's see, 2 times 4 is 8, plus 2 times 7 is 14. So I would get 22. So the perimeter of the first rectangle is 22. Now let's double check the second. So we get 1/2 x, which is 4. So 1/2 x is 2. That's the width of the second rectangle. And then I get x, which is 4 plus 5. You know what? I have a typo all the way at the very beginning. This right here was a 5 all along. I don't know why I wrote it down as a 2. So 4 plus 5 is 9. That's the length. So let's check the perimeter. The perimeter is going to be 2 times 2 plus 2 times 9. That's going to give us 4 plus 18, or 22. So everything checks out. Now, one thing that I do want to remind you of is when you're dealing with any kind of a word problem, write your answer out. So we would say the width of the first rectangle is 4, and the length is 7. The width of the second rectangle is 2, and the length is 9. So anytime you're dealing with a word problem, write your answer out in sentence form, okay? So again, a really quick recap. We already know the 4 steps to solve an equation. If an equation contains a lot of fractions, eliminate the fractions. Do not try to work with the fractions, get rid of them. The way we do that is we find the LCD. We multiply all terms by the LCD, and then we simplify and solve like normal, okay? Whoops. So that is how you would eliminate fractions. Again, I tell my students, don't try to mess with the fractions, get rid of them, okay? They just complicate an already lengthy process too much. And so generally speaking, if students try to keep the fractions and work with the fractions, they end up making huge mistakes, or they get so lost in the process that they can't finish solving the equation. So get rid of fractions, okay? In the next video, what we're gonna do is we're gonna look at how to eliminate decimals. Now, decimals are not nearly as complicated as fractions, so when it comes to decimals, I leave it up to the student. If you want to get rid of them, get rid of them. If you don't, don't. Fractions, non-negotiable. Get rid of the fractions. All right. So that's it for this video. Good luck and see you next time.